Okay, yeah, welcome back, team. So I was talking about the use case, right? So how the organizations are considering thinking of optimizing the resources. So at the end of the day, everybody has to optimize their cost, right? So as I was saying, the previous organization, right? They have data coming in from multiple countries. Okay.
Correct.
So the data comes from China, from Australia, from wherever Costco is, all around the world, around 7 countries or 10 countries, whatever, in Europe and all of that. So just to facilitate the time zone, right? Some data comes in the afternoon. So if I just run it in the morning, they have to again wait for 2 days until the next day, those state data. So just to facilitate that, some of the pipelines they were scheduled to run at 7 a.m. in the morning and 7 p.m. in the morning, so that it covers all the time
Both
zone.
the zones, yeah.
Yeah, twice, right? So morning you get all the data. You have all the data for the dashboards to look at. Gas data, how much gas was sold at each of the store across countries, each country, kind of that information. So similarly, it's the business justification. And other pipelines, they were all running just once a day. Like um, we use we we get pharmacy data. So pharmacy has 3 different jobs, and it only runs once a week. So 3 jobs run on 3 different days in a week. So one runs on Monday, one runs on Wednesday, and one runs on Friday. That's it. So different companies send their external vendors, send their what you call price list, basically, uh, and they run it on Friday, so that the next week the prices are adjusted, and they run on Friday. So Monday, Wednesday, or some other reconciliation or other jobs that run, it's not that important. They run it, but still Monday it might fail, Wednesday it might fail. They still have the entire week to go back and correct and fix and rerun those jobs. So it's basically the entire 1 week they look at, the window to run and keep the things up to date and all of that. On the other hand, as I talked about, the other gas data do like twice a day to run the jobs. So basically, I was saying business use case. So you have to keep a tab on how much resources you're using. So initially, this also started with DLT pipelines, Databricks. They enabled a lot of pipelines, but then looking at the bill, they went back and did more analysis, and then business justification, and retired some of those and converted into DBT. So there's another tool called DBT. It's also SQL based, where you can write transformations and process. So they converted to DBT and then converted to batch jobs. So that's the premise that I was saying, right? So it's not like it's available, it's powerful, all right? So, but it depends on the business justification when you want to use it. So even when you are doing this, keep a tab on the resources and see, just check on a daily basis at least how much it is using, what is the cost that is coming up, and keep a tab on that. Okay. Yeah. So, but at least, I mean, run the recording multiple times, run the notebooks on the cluster. But when you actually have to enable the job or streaming, see, as I said, right, you can run the file streaming, you can run the or rate streaming, everything on the community edition. Okay. Only if you want to run event hubs, you have to go to Azure account. That's part. Or if you want to run DLT pipelines, that we are gonna do in next week or so, we'll start introducing that. So that's when you also have to have the Azure account to get that. Okay. And now I'm saying that DLT is going to take much more resources to run than the event hubs. So just be careful how you run, what you run. But still, you have to have that hands-on experience. At least, otherwise you wouldn't know all of this, right? Once you try, you know all of this. So you can talk about this in any of interviews we talk about any challenges you faced. You can talk about this. Yes, we kind of so you build a story around it. Say yes, we kind of converted our pipelines to Delta Live tables, and then at the end of the week or end of the month, we had an issue with the huge cost that was coming in. So we have to went back and do the redo the justifications, and we had to kind of scale down or retire some of the move the some of the DLT pipelines, convert them into batch processes, maybe database batch process, and run them daily or hourly batch jobs kind of a thing. So it kind of reduces the cost, put some numbers, build a story around it, and say, yeah, by doing this, reanalyzing the cost versus benefit ROI analysis, and moving some of the DLT jobs into the batch, we have saved this many dollars, $20,000 or $30,000. You do see a difference of almost 50 to 100K, right? See, just for the personal compute, if you're seeing $300 estimated, just look at how much a company will extend if they leave it running DLT pipeline, right? So the bills do run into millions, and or at least 500,000 or something. And when you do this kind of analysis and then at least retire 20 to 30% onto the batch, even 10% of, you say, 500,000 is, you're saying $50,000 for the company, right?
Yes.
These kind of things you will experience only when you do hands-on. You have to be careful, but this helps you to get a perspective. Suddenly you can connect, you can talk about things when you're in an interview or something. So that makes the other person also feel like, yeah, you did in the real environment. You have been through these kind of scenarios and issues, and you know about how to handle kind of. Okay.
Yes.
All right. Good. So how are you guys? Raju, Varsha, Naina, Manideep, Hitesh?
I'm good. How are you?
Good, good, good.
Same.
Hi. Hey. Who's on the phone? I don't see the name. Hey, Venkat. Who's on the iPhone? Somebody, I don't know.
Hi, Harun. Yeah, looks like Srini did not join today.
No, Srini is not well.
Oh, okay.
So he is down with flu, I think.
Okay.
So he's not joining. No, I said somebody's joined on iPhone, so I don't know. It's in mute. Oh, Lahari.
Yeah, Harun, it's me.
Okay. So I see a couple of people have submitted the notebooks, I think. Who all did? One second. Yeah, Lahari has submitted and Raju has submitted, right? So you guys were able to do the streaming using event hubs and the fraud collection data.
Yes, Harun.
Okay, nice, nice. Okay, I didn't get a chance to look at it, but I will do it today or tomorrow, this weekend. I will do that. Okay.
Yeah.
All right. So rest of the team, did you face any challenges to try it out, or
Yeah.
how?
I was using the toll data because I wanted to go with the
Yeah, Anush, you get an excuse.
Okay.
you
Uh,
you had a very high bill, so
I
you
was
get an
talking.
exception.
But actually, one thing I wanted to share, Harun, is sorry, I don't want to take too much of time from the class, but one specific code. a block which I'm using. It's not giving the rows back. Can I share here just to explain? That's fine.
Yeah, you can. So, what is it? Something?
I'll share my screen.
Yeah.
I am not. Are you able to see my screen?
Yeah.
So I was just putting the toll data, right? And so if you see here, it's coming to the bronze layer
Mm-hmm.
and the body and the spine. And then I was just creating this stuff because I wanted to play around with this nested structure where we have this car model object within this. Okay?
Mhm.
So this was fine. I created it this way. And then I was able to move it here. So if you see the car model, it's coming fine.
Mhm.
Each of these objects. So then from here, when I put in silver table also, it was fine. It's coming here. Right? But the problem is when I was trying to run, I was just trying to do some aggregation based on this silver data. Right? So you see here it's there, but when I'm doing, when I was trying to aggregate it and do a group by, and this is again, I was doing group by state and something else too, just to get the filter on the issue. I was just removing all of this, but you see, it's not getting any rows now. And even if I do a simple select, you can take out this group by and just run this piece, right? It still was not giving any data back. But the data is here.
Okay. Mm.
I just took out all the window and everything just to make it simple.
Can you scroll up? So df.display is showing you the data, okay? And it is not okay. Did you check separately just if writing a SQL and see if the data is there in the silver table?
It is there. So go actually, you have to go.
You have to activate SQL warehouse.
That
You
was
can just run the %SQL there. It's easy. You have the cluster up.
No, the cluster is my subscription got disabled.
Oh, okay. Yeah, we'll look
Okay,
at.
yeah, I'll upload this.
Sure. It's just, I think, when you restart your cluster and you change any of the schema, sometimes the checkpoint does not reconcile. There might be compatibility issues. So if you have seen it's correctly coming in, that just check if the data is actually writing to the table, because here you're just displaying the data frame. You're writing to the
In the table, but displaying the data.
reading, and you're writing here, but you're not displaying what you have written. You're only displaying again the same data frame what you are trying to write. So it does not actually tell you whether it has written. So there is some error that says at the top. Can you see that? Okay. See, it used to read from another delta table according to checkpoint. This happens when you change the code to read from a new table or you deleted and recreated a table. Please, so it's just like a mismatch. All you have to do is change your checkpoint when you run that. And then it will run.
Okay.
And then, yeah, you check in the actual silver table from separate window, just write a %SQL and see if the data is actually coming into the database.
Yeah, I'll do that. I think so.
Yeah. Okay.
Mm.
All right, guys. Okay. I think it's a good discussion. It's not that always we have to, cover topics and run through so many things. It's these kind of discussions that help you in, talking to people. Code you can write anytime. You just take some AI assistant help. You can always write the code. It's kind of these use cases and scenarios. The more you discuss, the more you talk about, the more you feel confident, when you talk to people about your work experience. Okay, so all good. What I'm going to do today is, so we have, if you look at the event hubs or the data that Anush was showing, so it's a JSON based, and then you see there is a nested structure in that. Okay, so today we will cover how to, go through a JSON file, parsing a JSON file, and after that, based on the time we have, so I will start talking about the Spark internals. So we have been writing the notebooks and executing the jobs, but what goes on behind? How does Spark actually execute these jobs? How are the resources? How is the distributed computing happen? How all of these things we will start, and maybe this week and next week, tomorrow, we'll cover the internal Spark internals before going on to more advanced. So, I mean, internals is a kind of advanced topic. So we will touch upon that. Okay. So what we'll try to do today is this simple JSON file. So this we all know. It's just like, how you did your weather data, your taxi data, right? Same JSON processing file. Then we will try nested JSON, which is a simple JSON file. If you see here, this is what like Anush was trying out with a nested structure block. Okay, where ID and name are just key values. Attributes is again a struct field. Within that, you have a grouped data, basically hair color, eye color, height, weight. Some may have all attributes, some may not have all attributes. So we will see how to process this kind of data. Then we will go into a bit deeper, where you will have a data, key value pairs, a struct within that, which is address, and then an array of elements. So orders. So in the customer will have one address that he is currently using. He may have multiple, but say this is his billing address that we are processing right now. Sorry, or delivery shipping address basically. What are the orders that we are shipping? So he has 2 orders here. So it's an array. Okay, array of elements. So how do we process all this data? There will be, in real world, there will be much more complicated JSONs that you get, more nesting, level 2, level 3, level 4 kind of. So you have to process all of that to get the attributes and flatten the tables. Okay. So this is what we are going to do this today. Let me start, open this. Oh, I forgot to get my compute up. I think it's disabled. Let me start the compute. So otherwise, how is the team feeling in general about how we are progressing with the learning? In general, about how we are progressing with the learning? Hello?
Yeah,
Uh,
Harun, it is
Yeah.
understandable,
Am I
but
audible? Naina?
it's going good, Arun. We have to practice on it.
Okay. Yeah, definitely you have to practice, but how is the practice going?
It's good, Arun. I'm doing this notebook, so I'm on it.
Mhm,
So I've done setting up my account,
mhm.
so
Manideep,
it's good.
Pritesh, Varsha. Varsha, are you catching up?
Yeah, I am catching up. I'm trying to do the first assignment.
Mhm.
So I'm gonna like submit all the assignments soon.
Sure, sure. Yeah. Take your
Yeah.
time. But yeah, it's good as long as you're on the path progressing. It's okay. You might take a little more time initially, but that's totally fine.
Yeah.
Manideep, Hitesh, how is it going with you?
yeah, Harun, it is understandable, and in order to get more hands-on, I need to practice more.
Okay. Hitesh?
Yes, Harun. I don't have any problems for now.
Okay. Good, good.
Yeah.
Hey, hi Shiva. Morning.
Hey, everyone. Good morning, everyone.
Lahari, I think you are, at pace. You already done the streaming thing, so you're good with the concepts, everything?
Yeah, Harun. So far, it's good.
Okay. Raju? I think
Yeah,
Raju is also-
so far it's good, but I need to improve more practice.
Sure, sure. Yeah, definitely. We all need to do more practice. If you can take at least 2 hours a day, it should be more than enough. I'm telling you. Just
Yeah.
block 2 hours every day.
Okay.
Or evening 8 to 10 or 9 to 11, whatever it is, when you get some time when family, kids, friends, everybody is out or done for the day, take the time out for yourself and start working on those things. Or early morning, I mean, if you're a morning person, whichever it is.
Sure.
Yeah. And do let me know if you're stuck, reach out to me. We will just schedule some time, 15-20 minutes, and work on that. You don't have to wait until the next week's class kind of to discuss that.
Sure. Thank you.
All right, great. Okay. Venkat, how are you feeling? Are you good with all
Yeah,
concepts you're discussing?
yeah, feeling good, but only when I start, like I want to do practice and like data live table streaming and event hub, but I start my office environment, but could not finish the assignments, and so I want to concentrate more on this. So
Okay, good. Yeah.
yeah.
All right. Okay, so let's get back here. Right. Okay. So let's get back here. So I said we're doing the JSON file processing today. Let me see if I'm able to get this. It's still working on it. But so first thing, we'll start with simple JSON. So I have shown you the path, right? So it's just like what we have done earlier. It's gone somewhere. Yeah, here. Okay. So name, age, and city, just three attributes. And right? This is the JSON format. You know what is a JSON format? Anybody? Let me first come with the basics. Maybe the team may not be exposed. JSON file. Raju, know what a JSON file is? Or
No idea. I
okay,
know the JSON file, but I don't know the format.
okay. So it was actually, I think, started with JavaScript object notation. That's what JSON stands for, I believe, as far as I remember. But it is just a representation of the data with key value pairs. Okay. So all the data is in key and value. So there will be a key and there's a value. And it is treated as an object. Now each row will be one record. It may not be row, as we said, as it gets complex. Your data is enclosed in these braces, whatever you call flower brackets, braces, whatever call this symbol inside this. So as you go and build nested structures to see what does my record look like. Okay, again here it starts from here until here. This is one record. In this you have key value. Keys, ID, values, this, name, this. Attributes is a key and the value is again a structure. So within the structure, again, we'll have key and value pairs. So it's kind of recursive. Within this, again, this can be a structure. Okay. So it can go any number of levels. You just keep adding, hierarchy within this hierarchical structure to represent. And one thing about this is that your attributes, columns, right? So ID and name and all of this, the header information is repeated for each record. So basically you will get the size of the data will be more compared to CSV. Remember in CSV, what we will do, we'll have ID, name, all in the first row. So it is repeated only once in the file. And then you will have all the data. But in JSON, every row record or every record will have the attribute name. So you kind of repeating it. So the volume of the data in the file will be more, right? Obviously. Right, Naina? Hitesh?
Yes, sir.
Right. But on the other hand, what is the advantage? The advantage is you can represent the hierarchical structure. Okay. So in the CSV, if I have a customer and 10 addresses, how would I do that? So I have to again anyway repeat the customer with address 10 times. Now the repetition comes in the CSV file. But here in the JSON, the customer can be at the top and 10 addresses can be represented inside that. So which means that now all 10 rows are consolidated to one row in JSON, right? So this is the benefit, the other side. So it will compensate for that. So basically when you have more hierarchical structure, parent-child relationship, information related to different attributes, so JSON is better. The other thing is you would have better control on the attributes and structure in this. In CSV, a column is there, a column is not there, missing, the structure is missing. You have commas somewhere, it flows into the next cell. So all those kind of issues with parsing will not be available. And then, as I said, as more and more hierarchical structure it goes, it is easier to represent in JSON. On the other hand, once you have all of this hierarchical structure, the onus is on you to parse this and again get back into a flattened table. So parsing becomes another additional task when you go with the JSON. Whereas in CSV, even if it is like one order with 100 items is given to you for a customer, the CSV will come, say, with 100 rows. And then you parse each row, so you get 100 records. But here you get one record with order items inside it, 100 items. So you have to parse all of that, right? But again, so in JSON, you will have more control over the schema as well. So if you don't have the let's say attributes, or you can just keep those attributes which do not have. I mean, again, you can enforce that, it is expected or not expected, that kind of rules. But more or less, yeah, this is the JSON. Now within this, key value pairs. So it can be a string. You see here number. So you can represent numbers in values. You can represent strings, all data types in this, float values or string values, all of this. Now this is called a structure, right? Struct. Now within the Python, when you are parsing this in the Python, what we call in terms of Python is what do we call this? Key value pairs?
Dictionary.
Dictionary, yes, exactly. So this is called a dictionary in Python, which has just a key and value pair. In Java also you call this map, a map object where it will have again key value pairs. Now this, where you have square brackets from here to here, this is called, what is this called? Lahari?
Array.
Anush, anybody?
Array.
Array, right. So if you have square bracket, it's called an array in Java. In Python, it's more or less like array or list, or more interchangeably used. So we call it a list. A list having a dictionary inside it. Okay. This is a dictionary having a array list inside it. So the basic rule is that you have to understand in a JSON, when we are representing to parse, a list can have an array can have a list inside it. That's it. Those are two rules. A list can have arrays inside that, and an array can have a list inside that. So using that, you can navigate through the hierarchy. So list can have array can have list inside the list. Again, you can have another list, or you can have an array inside that array, you can have list, so on and so forth. You can keep adding the hierarchy based on the structure of the object. Why I'm talking about these two rules is that when you parse in the PySpark, you use the same two rules. What you do when it is a list, what you do when it is an array. These are the two things that you have to keep in mind when you parse the JSON files. And as I was telling you, the database, Parquet files, and JSON files. These are the mostly used formats in the organizations. Then comes your CSV. Okay. Most popular ones are these ones, Parquet, JSON. Database is always there when you're reading from any external database. So these two formats. Any questions on the file formats?
I don't want quick comment on the JSON files. I think one of the use cases that we have encountered in my work environment for the last few years is APIs. When you're reading the APIs, the common format is the JSON format. Yeah. So you will need to think about how to parse it, when you extract it. You want to convert it into CSV because you need to think about the downstream application, whether you're able to read the JSON file or not, and then, convert into CSVs. So APIs is one of the common use case, when you try to make an API call and, get the data.
Yeah, no, good. Thanks, Shiva, for that. I'm just okay. So you can see here, this is the file I have: name, age, city, name, age, city, name, age, city. Okay, so this is the file, simple JSON that we have, backslash and says, the file that we have. Parks PySpark SQL types import file path is this. Spark.read.json, because it's just a simple, we have already been doing this. And then display will actually display your, it will automatically parse. There's no arrays or list. So it will just parse the file and display data here with the attributes, age, city, and name for each of the record. As I said, we can enforce with struct type. So I have name, age, city in the structure. Spark.read schema. I'm providing this schema here, how to read the JSON file, and .json is the format, and I'm giving you the path. So same file, simple JSON, here also same file. So obviously the output is same. So if you read this schema.json file path, you'd still get the same file. Okay. Now, nested JSON, I was showing you. So we're going to read. So this file, ID, name, attributes. So sometimes the file can be split into the multiple. The record can be split, split into multiple lines. So from here, till here is one file, one record. Not here, sorry, till here, right? So it is spread across multiple lines. So if it's not flattened onto one line, we use this option, multi-line is true, so that it doesn't get skewed. It reads properly until the end of each element to make it as one record. So JSON path and display. So when you display that, you see here, you get ID, name, and attributes. So if you look at attributes, it says struct. Okay. So see, you have not provided any schema here. You are just asked it to parse the JSON file. So it has automatically deducted this as structure, as a struct with these attributes inside it. So you can see the data, eye color, hair color in these two items. Now this is a key value pair. So what do we call key value pair structure in PySpark in Python? Is a dictionary, right? So whenever you have a list, dictionary, okay? Whenever you have a dictionary, how you read that? How do you parse is using the dot notation. Okay. And again, you see a list, a dictionary will always result, a parsing of a dictionary will always result in the same number of rows. It's a one-on-one. You get multiple columns, more columns. Okay, you are splitting when there is a dictionary, you are splitting into columns. So you get more number, the output has more number of columns than the input. The other way, when you are doing an array, the output will have more number of rows. So it's a explode. So the array will explode into rows. The list will explode into rows. The dictionary will explode into columns. Okay, remember this. Now I have this dictionary called attributes. I do attributes dot whatever the attributes inside the structure, eye color and hair color. So I am reading column of attributes dot hair color and renaming it as hair. And similarly, attributes dot eye color and renaming it as eyes. So here you see, you have 1, 2, 3. Here I have 1, 2, 3, 4 columns. I have not selected this attribute, so it is dropped. And it's not dropped actually. In the df out, I have only selected ID, name, and 2 more columns that I exploded or parsed from this column attributes. So attributes itself is still there in the df. not in df out. So df out has this. So I can still say df.display as well here. It will show the attributes also here. So when I parse this, so the original one is attributes. From this, I have parsed hair and eyes. Here. Any questions on this? How do we parse JSON?
No. Good.
Okay. So this is the dictionary part. Now we are coming on to the nested JSON with arrays. Okay. Just give me 1 second. I have something to do. Okay. Right. Okay. So now nested JSON we talked about here. So we have key value pairs, right? And then we have a structure for address. So this is a dictionary. We are going to parse it using dot notation. We'll say address.city, address.street, and address.zip. So you get 3 new columns. Orders is an list, array or list. So it will come into each order will be new row. Obviously, the entire information has to be copied with each of the order lines. So number of orders. So orders will go into one struct, second struct, and inside that, then you parse again with the dot notation. So in the struct, order ID, product, and quantity. So that's how you parse. You first explode it multiple rows, then you get, if it's a struct, then you parse it with the dot notation. So what we are doing here, reading the file, multi-line is true, JSON file path. So when I run this, so what do I get? We get a structure which is address. If you see, it has city, state, and zip. Age, ID, name, or attributes. Now, if you see here, orders is an array. Okay, array of structure again. So if you look at this structure, it says array. It has 2 elements in this, 0 and 1. So in 0 is a struct of these attributes, and 1 is also the first row of this. So how do we flatten this? First, what I'm doing, flattening the address. Okay, I'm saying address.city, address.state, address.zip, drop address. So I'm just dropping the original this address column because now I have split it into the individual attributes inside that structure. Okay, so I get age, ID, name, orders. I have not done anything, so it is copied as is the array. for each row. City, state, and zip I get here. I have parsed it from the structure. So far, good. Manideep, Larry?
Yeah, Harun.
Okay, good. So we have parsed the structure. Now next is parsing the arrays. So when you want to parse the array, you have to use with column order explode. So you have to use this function explode when you are parsing the arrays. So explode orders as again order. Then you are dropping the old this one orders column. Okay, so when you display, what happened? df flat is not defined. Why didn't I run this? Okay. Okay, so now here we have age, ID, name, city, state, zip, and then order. See how many rows are there here?
3.
3 rows. So earlier we used to have 2 rows because this has 2 orders, this has 1 order. So this row is split into 2 rows because it has 2 orders. All this information with the first row and all the information with the second order, first order and second order. That's what you see here. First row with this order ID is 101 that you see here. Second row order ID is 102. So when you parse a array list, so you explode it into multiple rows. Now that array is done, what is it we are left with here?
Structure.
Object.
Yeah, it's a structure, right? Struct or dictionary, whatever you call. So now again, you parse this using the dot notation. So output will be same 3 rows, but you get again more columns based on the attributes within this structure. So what I'm doing here now that order is my column in this data frame, dot I can use order ID, product, quantity. And then I'm dropping the original this order column after I add these columns from this. Okay. And I get the final. So this is the final data. For this ID, age, name, city, state, zip, order ID is this, laptop and one, so order ID is this, product, quantity. And for this is the different ID. So you see here, based on number of orders, the number of rows are repeated here for each order information. Got it? Oh, you don't need to worry about this. So basically, if you have a table, you can define all these columns and write this data to the table, just like any other processing that we are doing. So this is how you do the JSON parsing. Now, when you go into the event hubs data, right? So we were looking at the event hubs data last time. So content type is JSON that we selected. And if you look at these information, so this is just the flat key value pairs that we did. Okay, just one struct. The same with the weather data. there is no nested structure, nested struct, or arrays or dictionaries in this. Click stream data is also same, flat, one-on-one, no complications. You just use the same attributes to parse. If you go to stocks data here again, now you see in the stocks, you have a symbol. Price is a struct, right? So you have to use price dot currency, price dot value. Market cap is also again a struct, and use market cap dot currency dot value. These are flat. So basically you only have structs in this stock data. You don't have any arrays or multiple line items. So you just kind of parse it using the dot notation for the struct. Fraud call detection. This is again flat data. You don't need any parsing in this. Toll booth. Also, it's just the struct data. So no arrays in this model. Okay. What you can actually do if you really want to try out things, put custom payload and JSON here and use this file. So not here. Up till here, I think. Yeah. So you can use up till here. Okay. And write the file to parse this. So try to send this from the event hubs and then parse it. Write a notebook, same thing, and parse this JSON. So this is how the actual file data looks like in the organizations. It will be, little more information will be available in the file. Okay.
Okay.
Yeah.
Okay. So try this out. I will also send you these sample files. I'll update it today in that document. Upload these files as well. I'll just put JSON file zip, and then you can download and use that. But this is how you can use. So this will tell you how to use this custom payload as well. That you can use your own payload here.
Okay, we can download this one from Kaggle, or just you are sending that one in the file?
I will send these 3 files in a zip and then add it in the document here.
Okay.
So you can just download it from there. It's a simple JSON file. You don't need to go to Kaggle for this.
Arun, I think in the Databricks file system also, there are a lot of JSON files to play with, right?
Yes.
I'm trying to find which folder actually. Yeah, I'll post it here when I find that, the data set.
Yeah, you can start with these simple things.
Mm-hmm.
And when you're comfortable, you want to opt for the challenge you want to play, there will be more complex JSON files to find. Okay. Well, a lot of files you'll find in the open source as well on the net.
Yeah, Arun, one more question. Sorry to ask this question.
Yeah.
So the event hub one, like we can do from Databricks environment also, or it's we have to have like Azure portal required for this.
Event hubs is a pure
like
Azure,
now what?
Azure service. If you
Azure service.
have your account, you cannot see. So this is Azure. There is no Databricks here.
Oh yeah, correct. But this is Azure service, but this event hub also we can do from there. I mean,
Event hub is part of Azure only. Event hub's namespace.
Mm-hmm.
event hubs. This is all part of Azure. You need Azure account to do this.
Oh, to do this.
It's not there in the Databricks.
Oh, even it is, we need, if we can do that one in AWS also.
AWS is, it will have a different streaming platform. I think not Event Hub. Event Hub is Azure.
Oh, Event Hub is Azure. Okay, okay.
AWS will have its own streaming, similar thing, but they will not have their own product or their own tool to do this.
Oh, okay.
Yeah. I will check that what you can use for AWS.
Oh, yeah. Basically, we are using AWS. That's why I just want to make sure.
Yeah. Okay. We'll see. We'll explore that.
Okay.
Use for AWS. Okay. All right. So we are good with this. If you just send us. I'll see you're receiving events here. Sure, shape 3, 4, 5, 6, 7, all 10 events. New events 3, 7 events you are seeing here. Then you can see all 10 events that were published. Okay. Just make sure when you are publishing, as I said, only use this part from here to here. If you use the entire thing, you will be confused because the entire thing will be sent as one event. So within the event, you will have two IDs. So if you are using it as an event, not as a file, just take from this to this part. And then you can repeat send this when you are publishing. Okay. You will get the same data 10 times basically. Okay. All right. So this is about the JSON files. We spent enough time on this. Now let's jump into the next part where we call the Spark internals. Okay. Or we call it how Spark processes a DAG, what we call a DAG. So DAG basically is directional acyclic graph. So it has a direction. It is acyclic, which means that does not do a kind of a go back in loop or circles, and it has a graph kind of thing to display. Where is that? I wanted to show. 1 second. Let me bring that file up to discuss. Good. Okay, let's just talk about this now. We have okay. So do you see this picture?
Yeah, Harun.
Okay. So how does it look like? All maze. Okay. So it's basically how when you run a Spark job, how it represents within the processing. In phases. Each task it divides into, and then it executes all of this. So it creates this kind of a graph, and then processes as per this graph. It looks very complicated, but when you break it down, it's very simple. Okay. There are stages. So whatever job you run, obviously you will, let's say you want to build a house, right? You cannot just go start and, go in and start building the house directly. You'll kind of first split it up into stages. What I want to do. I want to build a farm. First, I want to do a architecture and design, right? So how I want to build the house, how I want to look at it. So without the architecture or without the design, do you go and build the house, start building the house? All right. So we need to have an architecture or design of the house first. So these are, I will have 5 bedrooms. I will have kitchen here, and then there is vastu, east, west, north. I want this on this side, this on this side, all of that. And the plumbing has to be done. It has to go from here, the water connections and electricity and all of that. So the same thing when Spark does is when you give a notebook to run, it does not directly take and start running from line 1, 2, 3, 4. It doesn't do like that. It scans the entire thing, and then it builds its own graph, how it wants to execute stage by stage. So that is why you see all these stages. Each stage will have again multiple tasks within that stage. Okay. So stages, once you have a design, now you want to do the start building. So let's say foundation is one stage. So you have to dig ground, put pillars and put the foundation, that's stage 1. Then you start building the walls, stage 2. Then you want putting in the slab, stage 3. Then you want to put windows, doors, stage 4, interior, stage 5, and all of that. Then there will be dependencies, right? You cannot do windows until there are walls built, right? So windows cannot come before the walls, correct? Are you guys with me?
Yes.
Yeah. So there is a dependency. So this stage has to come after this. Or in other words, by the time I want to do windows, I have to have all the walls ready. Okay. Now, the windows has to be ordered, pre-ordered, right? So they have to all be ready and come to fix it. I cannot go say, today I'm going to fix my windows. So where are the windows? I don't have. Okay, go and order windows, get it. You cannot get it. So you have to order it early so that you get the windows delivered on the day when you want to fix, or before the day you want to fix it. So all of those dependencies are put in here, displayed here, how you want to run this entire job. Okay. So each stage, basically a stage is when you go and do a data shuffle. Okay. Each stage, it moves to a different stage when there are different data sets, or when there is a data shuffle between the within the data frame. So when does a data shuffle happen, right? So we said each data frame in the distributed computing, it is split into on multiple nodes, right? So data set is split into multiple nodes, correct? The data, it's not there on one machine because it is a distributed computing. You're doing on the cluster. So if you have 10 machines, Your data is split into all the 10 machines and processing happens parallelly in all the machines. Is that clear? We will come back to how that cluster happens and how we process all of that. Right? So whenever I want to shuffle, there is a data shuffle between the machines, or data is moving around. When we join two tables, for example, employee and department, the data, each, the keys, where is the department one, HR, this employee belongs to HR. So these two has to coexist on one machine. When you join, the join will be easier. So before the join, there will be a shuffle of the data based on the keys. When that shuffle happens, there is a new stage created. So each stage will represent simply a data shuffle, whether it is a join, whether it is a group by, whether it is a coalesce or repartitioning of data. So currently my data is 100 partitions. I want to redistribute it to 200 partitions. So then there is a data shuffle and there is a new stage. So these kind of activities or actions result in a new stage boundary. That's one U term. So if you see here, this and this are merging into one. What does this represent? Merge.
Union.
Sorry, come again.
Union.
Yeah, it's a join, right? It's a join. So this is, say, table 1, table 2, reshuffle, data, repartition or something. Then these two are joined here and then shuffle, repartition data. That's it. So there are two data sets. We are repartitioning, joining, and finally we are mapping the partitions, exchange. So whenever there is a data, that's all it's doing. So this is called a DAG. Now we will see how a DAG is generated. Okay. So this is the employees data. So we have read this data, right? DF employee. We are just reading from this data set, employee salary data set. And it is giving you the metadata. What are the columns and what is the data set name, columns, and data type of this. Okay. But if you look at here, there is no action that is done in this. So these jobs are basically just to scan the metadata. Okay. Now, if I do a display, now it actually reads the data. Okay. Now there are 3 Spark jobs. If I go view, click on this, see now there is a stage. Look at this. It's just one box. Remember, we looked here, just try to correlate just this one. Okay, one box we are scanning. The whole stage code gen is actually basically where it generates the code to read and all of that. So don't worry about that. Just look at this, just one stage here. Let's go here. and read department. Let's say display. This is another scan CSV data to read the department. Okay. So what I want to do is repartition. Okay. So basically, let's say it's distributed into whatever the file size, for example, it has some kind of partitions. So now I'm going to repartition it to 4. So final, there will be 4 partitions that employee data will be split into. Department will be split into 5 partitions. So I'm doing a repartition. So when I said whenever I do a repartition, the data has to be shuffled. All the data has to be put into 4 buckets or 5 buckets. That's the pre-partitioning that we are doing. So whenever there is a repartition, we said there will be a new stage that is created, right? So if I run these two, where's the tag for this? Sorry?
You need to display that to do.
Yeah. Let me say I go ahead and do a join on this, and then I am displaying here with group by. Okay. Now we go here to get the final stage. See now, the same thing that we were looking at here, we got the same thing here, same kind of DAG. It's generated here, right? Guys, are you able to see this?
Yes, sir.
Okay.
Why does it say skip? Because you ran the last here.
Yeah. So this
on
is
the
showing.
last.
Yeah, this is showing what is actually done by this job. So this is already calculated by the previous jobs. So each job has one calculated in the stage. So that's why it's already calculated. In this graph, it is showing skipped, but it's part of the entire thing, right? It was executed by other job, but the stages are, these are the final stages that is completely used to calculate this. This is the scan CSV first file. This is scan CSV second file. This is repartition, shuffle, and then join these two here, and final group by shuffle read. These are all the actions that are planned here in each stage. So if you go deeper, so you cannot see here. So if you see here all the stages that it was done, you can go deeper and see what it has done, details and all of that. You don't need maybe once you are more comfortable, you can go and see here what is the each stage and how does it correlate. See group by department name. All of these 5 stages here, it says group by department name. Shuffle read, how much it has data it has shuffled, how many tasks it has taken, what time it has taken to complete that. So all the data, how much it has shuffled, read, write, all of that it does here, all statistics. File path, which file it has read. So you can see all of those details, right? So everything is logged here in the monitor. Stages. You would have storage. When it is spilled to the disk, you can read. Environment, executors, what executors were used when you process this on the cluster. Since it is a single node cluster I'm using, there is only one driver. So if you have machines, multiple machines, your worker nodes will also be listed here. Okay. status, what is the storage, memory, how much disk it has been used, what are the cores it used, how many tasks, what is the completion time, all of that. Task time that it takes to process. So everything is here. SQL is basically, it will show you how it has converted and what SQL it was executed in each of these tasks it has run. Okay, so all those SQLs. Okay, so when you talk about troubleshooting, when you talk about in general, say if a job is not running, or if a job failed, or if a job is stuck, what do you do? How do you troubleshoot? Then you have to talk about these things. So we go to monitor, we check how many jobs or what stages it is, which stage it is taking time, or which stage it is processing, you will see here, or which stage it is stuck. Then we can go into that, dig deeper into that stage, and then see what are all the tasks and store environment. So go to executors and see how much time it is taking, why it is taking, and what it is processing, right? So you have to talk about these things. We go to monitor, we look at the jobs and stages. It will see which one is stuck, how much time that stage is taking, what it is processing, and then we look at troubleshooting or checking that particular stage or that particular task. Okay, so that's what you have to tell them. So if you see here duration, if you see any particular thing taking 100 seconds or 2 minutes or whatever, or if it is stuck, then you go and see where we are having that issue. For example, if you go this, you can see here, what is the adaptive, what is the Spark plan, hash aggregate, shuffle read, exchange, whole stage code gen, project. So what kind of join? So remember this, we will discuss what are the join strategies that we are using. Broadcast, hash join. Okay. Let's say if it is not broadcast, it is a shuffle merge hash join. Then we can say, hey, from the graph, we can see it is using shuffle merge join, but it has to use broadcast hash join because that is faster. The table is smaller. So maybe we can change this to broadcast hash join to improve kind of a thing. I'm just saying, so don't get too overwhelmed. We will discuss all of these. What is a broadcast hash join? What is shuffle merge join in the next class? These are the join strategies that Spark uses when you join two tables. Right? And then see how many shuffles or exchanges are happening. Can we reduce the number of shuffles? Because every time you shuffle the data, there is network IO involved, the CPU involved, and obviously the time, it will take more time to do that. Right? So this is, you have to, when you say for troubleshooting, you have to talk about these things. Okay, SQL, I think important ones here to look at is stages, executors, SQL. Okay, this JDBC is all fine, not now. So if you are doing streaming, your streaming things will come here when you run a streaming job. Okay, any questions, at least at high level? I'm not expecting you guys. Again, I'm reiterating, don't worry. You don't have to know each and every attribute or whatever you see here. What does this mean? What does this mean? What does this mean? You don't have to go that deeper. You have to have an understanding, at least at higher level, where to look for if a job is stuck or if it is taking too long. So basically, you have to tell them, we go to DAG and look at the DAG and see what are the stages, which stage it is taking more time, and what is the SQL that is using or the DAG, and see what kind of joins, if it is queued, why it is failing, which machine, which node, what is the stage, what is the task, and how do we rearrange, reshuffle data so that everything is equally, the load is equally distributed and everything runs fine. So these are the things that you should talk about. So to help with that, you have to understand what a DAG is and why these things are. Right? So this is the structure. This is how your job, a simple job that you have written, is converted into the plan to execute. Okay. Any questions on this?
Can I add a couple of comments here?
Sure.
Yeah. So I think, definitely, I think the DAG definitely gives you how the data is processing, right? So the other side of it, when you are bringing up the cluster also, this is like a single node right now. We are running it, okay? But tomorrow in your real time, real workloads, there will be multi-node clusters. So you need to understand how the data is distributed between the nodes. Okay, so this understanding will help you determine, oh, okay, I might need a 4-node cluster. And not that you'll be going and creating a cluster, okay? But it's just an understanding, like okay, what volume of data is coming in, how the data is being processed, and what are the joins that you're doing, how the merges are you're doing, and then you can talk to the people who create the clusters also better. If you understand how the data is processed.
Yeah, thanks, Shiva. You're right. Yes. So when you have that cluster, so most of the times when you see the same job or the same task, it will be finishing or running on some machines faster and slower on some other machines, some other nodes. So that is when we say, because of one node that is failing or taking too long, the entire job is stuck. So we have to go and check why that node is slow. Is it the node or the machine that is having a problem, or is it the processing on that machine or the data that machine, right? So for example, if you want to load some packages into a truck, right? And the truck has to go and deliver somewhere. And then you have, say, 1,000 packets, right? And you have 5 people. And you are saying the first 4 people, you load 100. And you're saying the 5th person to load the rest 600. So what happens? Or let's say not 600. Let's say you have, say, different kind of packets. Okay. For example, you have shoes, you have electronics, and you have apparels, accessories. And you say 4 people, you take up shoes and electronics, and 1 person to do accessories, which is like clothes. Okay. And in that order, say that truck, there are like 100 shoes and 200 electronic items, and then 600 are the accessories. Now the person who's assigned accessories, he has to load 600 because there are more accessories than shoes and electronics, right? So what happens in that scenario? We are not distributing by number, but we are distributing by category. But it so happens that some categories has more number of items than the other. So, right? It is possible. So what happens in that case? If the first person loads the shoes, can the truck leave? Or say in 30 minutes, the person who's done with the shoes and the other 2 people who's done the electronics are done. Now, 1 person who's doing accessories is not done. Can the truck leave?
No, it has to wait.
Right? So it has to wait until that person has completed loading all the accessories. That's when the truck can leave, because that's when the order is complete. So it has to take all the items. It cannot take half items and leave. At the same time, these guys who has already loaded shoes and electronics, they cannot go and load the accessories because they are not assigned to it. So they will be just sitting idle, apna kaam khatam, and they just sit. And that guy is kind of trolling around and loading. So these guys are finished in 30 minutes. The other person is still loading. And the truck guy says, hey, why is taking so much time? You guys are sitting idle, that the person is riding. Why can't you go and help him so that we can finish faster and leave, right? That is what you call redistribution, right? So when you say some node has more data to process than the other nodes, which is a data skew. Right? The data is
Skewing,
skewed,
yeah.
right? So you solve the data skew, you have to redistribute the data. That is shuffle the data around, repartition basically. Okay, now you say, man, this is not working. We don't go by categories now because some categories might have very huge data and some categories might have less data. So what we will do is everybody, all 5 people, start loading 200 items, whatever it is. It can be shoes, it can be electronic item, or it can be accessories. Right? So now we shuffle and repartition. We put 200 items. Okay. Now the 200 items may contain 50 shoes, 40 electronics, and 20 accessories or whatever, and that kind of stuff. But the load is now equal. Now all of them will finish almost in the same time, maybe 5-10 minutes here and there, kind of a thing. But it's not like somebody's completed sitting idle. Some machines have done with the processing and those machines are idle, but one node is still running and running and running for hours. The entire job is stuck because job is not complete until all the machines have done their processing. So the job cannot complete. So that is the scenario where you have to look at checking the reshuffling the data. Now, having said that, it happens when we are using our own cluster configurations where we define a cluster, a compute cluster, or general purpose cluster that we use, and we define the nodes and all of that. Now we have options where we have elastic, where we say you add more resources. That is when there is more data. Okay, so if you add 4 people, we think the 1,000 items, but suddenly there is 2,000 items. So we say, hey, you add 4 more people to process that. That is fine. But but that's not the same as doing by categories. Okay, in that case, even if you add another 4 people, again, in that 3 people will still be going and doing the same shoes and electronics, whereas the accessories will now have 2,000 and still 2 people, right? So that kind of you have to do the repartitioning to help with that. Now cluster size is one thing, but elastic is done. You add more power to process faster. And again, there is serverless right now. So you don't have to worry about how many people, how much thing. It will automatically check, do the repartitioning, redefining, adding resources, everything by itself. You don't have to worry about that. But you have to understand as a concept, this is what happens in the distributed processing by the Spark when you have multi-node cluster.
So as a data engineer, I think it's very important that you understand your data.
Yes.
So, Harun talked about all these, categories, and what you are moving, right? That is all data. So you need to understand, what kind of data you're pulling in, and everything. So in order to, decide, okay, what kind of cluster do I need? Or at least, work with your administrators, who brings up the cluster. But again, these days, I think, as Harun was telling, serverless. But again, you have to be very careful also there also, the Databricks decides, what kind of cluster that I want to bring, and process your data. But you need to understand definitely the internals, how it works.
Yeah. So this is this kind of, data skew where you solve it using a method called salting. where you add more keys to the data before you repartition the data. Add your own keys, your own prefix or suffix to the keys to make it evenly distributed. You can read about those use cases, but these were like early when clusters were defined for the jobs, before elasticities come in, before serverless has come in. These things have come in to solve those kind of problems. But you should be aware of all of those, and you should talk about those when you talk about, we'll also see what are the performance tips that we have to use when you do all of, improve the performance of the jobs that are running. It will definitely help.
Yeah, auto scaling is one of them. Auto scaling, the elastic, that you're talking auto scaling. Yeah, it should automatically scale up or scale down, based on your workloads. So
yeah. Okay. Now, so this is done. So sorry. So what's happening here? So when we are running the jobs, right? Is there now, I go back here. So I don't do a display and run this job. Okay. So I am asking it to read. Okay. But has it done that job? Has it read the data? Did you see the job running here?
Yes.
No, right? So until you do display, now if it has already run this, display means it should immediately display, right? But when I run this, why is it again running that job? Do you see the job that has run? Guys.
So I did not understand this. When you have the read statement on, it does the cluster is doing something. It's reading from the file path.
It's
So
just
that means
scanning the file. It's not reading the data.
Okay. So
Okay.
when you
Because if you see here, the third job, this is what is run the job here. You can see the stage, file path, and everything. This is scan text. See? This is always scanning and mapping partitions. What are the partitions? It has how many partitions and all of that. So this is something called, as I said, right? You will not go and immediately start building the house. You just first go use the design. The same thing what Spark does, what it means is it executes some in a process, in a method called lazy evaluation. Okay. What lazy evaluation means is that irrespective of what you do, how many transformations you write, how many commands you write, it will just read it, generate a DAG, and keep it. It will not execute until there is an action. Okay. So when you call an action like display or aggregation or write or repartition, right? Or collect. So these are called actions. All of that like read with column transformations, select, all of these are transformations. So all the transformations are just read, understood, and then sequenced. Okay, hey, this is data frame 1. I have to read from this file. Then I have to add these columns. Then I have to calculate this. Then I have to take a subset of this using this where class. This is the final data frame. Then I have to join this data frame with this other data frame that is coming in. Then write. So when you say write, that's when it says, oh, now this guy wants me to do something. We want to actually write it to the table. Now I have to write. What do I write? I have not done anything. I have just written down what I have to do. So now it will go back in sequence, backtrack, go to the first event. So based on the DAG, what it has to do, and it will start executing all of those actions, transformations, and then write. So basically, lazy evaluation means all the transformations are just logged and sequenced, making the plan as a DAG. When you have an action, that's when the actual execution happens. That's called the lazy evaluation. That's why you don't see any of the action happening until you have a actually execute a action on that. See, it just says just now less than 1 second. It didn't do anything. Okay. Let's get here. Join. It didn't do anything. Now I'm doing display. This is when you see here, now the processing is happening. So it went back all the way and did all the processing of all the jobs here to do this. Okay. So this is called lazy evaluation. We will also check this, how we are actually something called caching, how caching helps when we are doing this chain of actions. Every time I want something, it need not go and start from the first line. If the first 10 act transformations are common, and from there we are reusing them, then we can cache at that point. So when you run, it will go back, and when it sees a cached point, it will pick up from there instead of going all the way to line 1 to process all the data frames. I have read the file, I have run a filter and created data frame. Now, let's say I'm doing all the processing on one city. Now I read the data from the entire file and I filtered with that city, and all the processing I am doing after that is only based on that city. Okay. Now, when I do the actions, it should not go back and read the file every time, filter every time, and then you get the data frame. Instead, once I do the filter, I can cache it so that every time I'm going to access that, it reuses that same already cached data frame, which is already filtered with that city. So we'll revisit that. I will show you all of that information. But yeah, this is at the high level what is a DAG is all about, how to read a DAG, right? And what are the stages, tasks, and so what does it have? What are the tabs that it have? Sometimes people claim they have worked on Databricks or PySpark. They don't even know whether and what are the tabs or how to look at the monitoring. Okay, so you should be at least aware of all the terms. What is a stage? What is an executor? Do some reading. We will also discuss in the next class. What are the executors? What are the nodes? What are the cores? How does it uses, right? How are the stages? How many tasks each stage has? How does it define how many tasks it should execute? What is a task that level? So tomorrow we'll talk about how a data frame is distributed on multiple nodes. How to visualize. Whenever you talk about a data frame, you have to always visualize it that it is distributed on multiple nodes, on multiple machines in parts. Everything is not on one machine. So that visualization you should always have whenever you say a data frame. You should visualize that it's split in parts on multiple machines, multiple nodes. And we are doing processing on all of those machines in parallel. So whatever you write the code, okay, if you say I have 1,000,000 numbers and then I'm calculating square root. So all those 1,000,000 numbers are not on one machine. They are on 100 machines. And you are doing a square root on machine 1, that function. the code is going onto that machine and executing the data, the numbers that are present on that machine. You are doing a square root of all those numbers. Then on the second machine, whatever numbers are present on that node, you calculate. Then on third machine. Finally, the rival will bring the data from all individual machines together and give you, hey, these are the square roots of all the machines. Or when you are writing, it will write from each of the machine onto the database. So that's how the distributed computing we will discuss tomorrow when we get more deeper into the Spark internals. Okay, so I think that is all for today. Enough to chew on, think about, ponder, digest, go through reading, right? And tomorrow, be prepared to talk about these terms. Just at high level, we'll talk about it. Okay, so any questions before we wrap up today? I will upload the video and I will upload the sample JSON files today. Anything else you need? Any questions?
This one, Harun, this one will come from, so you are dragging this DAG visualization from Databricks, right?
Yeah. This is all that notebook. Once you run the Spark jobs, there is a job here. These are stages all here. Just go here on the job, right? The last one, and click on that view. So you
okay. I see. Okay, got it. Okay.
You get the DAG visualization.
Okay.
So you can also correlate here. 4 skipped. 1, 2, 3, 4 are skipped. The 5th one is executed. You go to the job just before that. How many are skipped?
3.
3. So 1, 2, 3 are skipped. 4th one is executed here. If you go before that, so because this is executing the first one. Now when you go to second one, first one is already executed, so it skips the first one. Okay, and it processes the second one. See here, first one is already processed, so it skipped, it processed the second one, but still it's dependent on this. It's reading the data that is processed by the stage 1, the first job. So if you go here, already the 3 stages are already processed, executed, and the data is there. So it is using that data, but in this job is processing this stage. That's how it is. That's why it says skipped. It's not like it doesn't want to do a skipped. It is skipped because it is already calculated by the previous job. So it doesn't have to redo it. It's just using the same. So it's just representing that as a whole figure. Otherwise, you will not get the entire picture of how it is getting processed, right? If everything is a one part, you will not know how to join all those parts. That's why it's showing the entire picture, but it is also showing what is actually executed by this job and what has already been done by the previous jobs. That's why how this you have to read the DAG. Okay, and you can also check what is the stage number: 57, 58, 59. 57, 58, 59, 60 are skipped here. Okay, so if you go back, it should say stage. Oh, the stage numbers are changed, but 56 is processed. This is same as the stage number 60 here. Skipped. Yeah, the same is here, stage number 60. Okay, that's how you read the DAG. Any other questions? So tomorrow we'll get more clarity on, what is a data frame, how is it distributed across nodes, how we kind of visualize that at each stage, how does the shuffle happen, what do you mean by shuffling, why does shuffle happen, and then during joins what happens. We will talk about that.
Okay.
Any other questions, guys? All good? Feeling comfortable, at least at high level?
Yeah.
Yeah.
Okay. Yeah. So as long as you're able to connect the dots, everything comes together. Okay. We'll take step by step. Don't get overwhelmed. It's not too complicated, but at the same time, it's not too easy to understand and talk about this. A lot of people don't even understand what these concepts are. Lahari knows, right? Lahari, you and me, we did some, interviewed some people for some,
Yeah.
yeah. So they don't even know what this means or what these concepts are. And they claim each of them have like 6-7 years of experience in working on this. So understand at what level we are exploring, at the foundation, to have a strong foundation, the basics to talk about. Okay. Appreciate yourself. You are doing the best kind of experience, practice, learning here. All right, guys, that thought I will leave you. Do more practice. I'll come back tomorrow. I will publish this in maybe a couple of hours. Okay. Anything
Thank
else? Good. Thank you. Have a good.
Just a second. So the DAG visualization is everything on Databricks, right? It's not on. Is it on Spark?
So see, Spark is Databricks. I mean, Spark is the engine, right? It's
Yeah.
how
Yes.
you run the notebook,
Yep.
right? You run Apache Spark is the software or the engine that uses to run all of your notebooks. Whatever you run, you write PySpark, it runs on Apache Spark.
The framework.
Okay. Databricks is the company that has created the Apache Spark. Now they support whatever, if you buy their product, they will support in your company when you implement Databricks. If you have any issues with your notebooks, if you have issue with any of your environment, your jobs, they will support you. They will give you the latest updates, licenses, whatever features, and then they will have their team who will help you when you raise tickets, when you have these kind of issues, they will help you and support you. So Databricks is the company that has actually created this software, Apache Spark. It is open source. Even if you don't buy from Databricks, you can still use it. But you are on your own. If you have any issues, you have to fix it yourselves. A lot of things that Databricks created as open source. Like you can use Databricks Delta, you can use Apache Spark, you can use Unity Catalog, that is also open source. All of them are open sourced. If you want, you can just take it open source, install it and use it in your company. They will, no questions asked. But it will not have their support. You have to fix or do everything on your own. So if you buy a license from Databricks, they will come, they will assess, they will help you in getting things onboarded, running, advice, support, all of that part. Okay. So just think of it. Databricks is not same as Spark. They are not two different processing things. Databricks is a company which has a product, Databricks Intelligence Platform product. In that you have all these components, like we have seen this earlier, that in that you have all of those Unity Catalog, and then your ML flow, your Databricks Delta, and all of that will be there. But you can also get that open source. It all runs on the Apache Spark. Is that clear?
Yes, sir. Yes.
So it's very important you understand. So this is very basic. Okay. You should not talk something, about, say, is it Databricks or is it Spark? So people will get confused. So you should be very clear. What is Spark? what is Databricks, what is Delta, what is Unity Catalog, how all these components come together, how these are, right? So give me 1 second before we wrap up. I think I have something I can show. One second. I was trying to see where that Databricks intelligence platform thing is. Yeah, let's see, maybe this should help. 1 second. Okay, so if you look at this data intelligence engine, okay, so this is what we do, right? Bronze, silver, gold transformation, ingest files, database, orchestrate, BI, and all of this. This is the architecture. Now, if you go to what Databricks is, Databricks Data Intelligence Platform. Okay. So what it gives you, Unity Catalog, Delta Lake, raw data where you store. So this data is going into your Azure ADLS, whatever it is. It has all of these Delta Live tables from Databricks. Workflows is from Databricks. Databricks SQL is Databricks. Mosaic AI, this is from Databricks. This is all offered by Databricks company. Unity Catalog is Databricks product. Delta Lake is Databricks product. These are all Databricks products. This is available free, Delta Lake. Unity Catalog is also available free. You can take on your own and create and use. So most of these are available free to use. Delta Lake, all of this. Now, using this, whenever you write a PySpark, Python is free, PySpark is free, you write a notebook and you run on your own. Using Apache Spark, you can run your own programs, PySpark programs. But if you buy from Databricks license, you will get all of these components and they will help you set up, orchestrate, and do that. It's kind of buying a service who can come and install and run and do the maintenance versus do it yourself, DIY. Just buy all the parts, or parts are also free, and you fix yourself and you maintain yourself. That's the difference. But Spark is the engine that runs these jobs, and that engine is used by everybody. Even Snowflake uses, Databricks uses, AWS uses. Everybody uses that engine because that's free. Wherever you need, you can use that. Does that help?
Yes, yes.
Okay. All right, guys. Thank you so much. Appreciate your patience. Have a good day. We'll meet tomorrow.
Thank you all.
Yeah, thank you.